Hello, welcome to section 4.3. We're going to look at how derivatives can affect the shape of your graph. So increasing and decreasing functions. If the original function is continuous on a closed interval from a to b and is differentiable on everywhere in between, then if your first derivative function's y-coordinates are positive, that means greater than 0 on that interval, then the original function is increasing. If your first derivative of that function has y-coordinates that are negative, which means they're less than 0, then on that interval you have a decreasing graph for the original function. And if it's equal to 0, that first derivative, then you have a constant function. So looking over here in our graph, here's the original function right here, graphed. This is decreasing from left to right. So when you find its first derivative, you're going to have negative y-coordinates because all those negative y's represent all those negative tangent slopes here. When I'm constant, when I flatline, all my tangent slopes are 0. And over here, now I'm increasing from left to right. They all have positive slopes for the tangent lines. So f prime of x has to be greater than 0. All right, example 1. Find the open intervals on which f of x equals x cubed minus 3 halves x squared is increasing or decreasing. Well, we need to find the derivative and set it equal to 0. Here we go. The derivative is 3x squared minus 3x. Okay, we can factor out a 3x, and we get 3x times x minus 1. We set that equal to 0. We're going to get x equals 0 and x equals 1. These are the critical values. Now, you might run into someone who's old school and says, well, you got to test the numbers to the left and right of 0 and 1. So what they'll do is they'll draw a number line with a 0 and a 1, and they put these two factors up above. And they grid this thing off. And they say, well, let's pick a number to the left of 0. Well, whatever's to the left of 0, that's going to be a negative number times 3. That's a negative number. A negative minus a negative 1, or excuse me, negative minus 1 is still a negative value. And a negative times a negative is a positive value. So in this area here, to the left of 0, that original graph is increasing. We pick a number between 0 and 1, say a half. Well, that's positive, so 3 times a positive, that's positive. But a half minus 1, that's still negative. And a positive times a negative is a negative. So that means between 0 and 1, your original graph is decreasing. And then over here to the right of 1, pick maybe a 2 or a 3. That's a positive times 3, that's positive. 2 minus 1, that's positive. Positive times a positive is a positive. So this part, this open interval, if you will, 1 to infinity, is increasing. Now you can do it this way. I say, no way, there's a shortcut. Here's the shortcut. If you recall, we talked about that right-hand behavior for polynomial and rational functions way back week 1. So if you look at your f prime of x, it has a positive 3x squared. That means the right-hand behavior is positive, and as long as every x intercept, that's your critical numbers, occur once or an odd number of times, you alternate signs. The only thing you got to remember is if by chance one of my critical numbers occurs twice or 4 times, then there's no sign change. Okay? So let's apply this shortcut. Find the open interval on which f of x equals x to the fourth minus 2x cubed is increasing or decreasing. Same thing. Find the derivative, set it equal to 0. F prime of x, we got 4x cubed minus 6x squared. All right, we can do some factoring. It looks like we can take out a 2x squared. We left with 2x minus 3. We're going to set that equal to 0. We're going to solve for x. Ooh, wait a minute. X squared. That means x equals 0 twice. Remember how we used to put those little subscripts there to remind ourselves? And add over 3 divided by 2, 3 halves. Make my number line. Now, you might, again, want to put that little 2 subscript here on your graph. That's up to you, just as a reminder. But right-hand behavior, on my f prime of x, I have a positive 4x cubed. That's positive. Then 3 halves occurred once. That's going to be negative. It's going to switch. Now, because 0 occurred twice, there's no alternating sign. So since both of these are negative, this interval here is decreasing over here to the right of 3 halves, that's increasing. So 3 halves to infinity, we increase. From negative infinity to 3 halves, we decrease. I don't know about you, but that's a lot quicker than testing point values. Don't you think? I do. Good. Thanks for agreeing with me. All right. Now, we have a special term that you might see in the homework. It's called a monotonic function. A monotonic function means that the entire original function is 100% always increasing or 100% always decreasing. If you get a combination of the two in there, it's not monotonic. This only happens, mono meaning one, that you get only one type of function, whether it's increasing or decreasing. All right, first derivative test. Our critical number C for f. So if f prime changes from a positive to a negative, then f has a relative max. If f prime changes from negative to positive, then f has a relative min. If there's no sign change, then there's no max or min. Okay? All right, so looking at our previous examples we had and their number lines, not only can we say, well, we know the interval where we're increasing, decreasing, and increasing, but let's find out if it's a relative max or min. Oh my gosh, I've already forgot the rule. Don't worry. I forget this rule all the time. Here's how I figure it out. All right, at 0, I just try to trace this. I have positive tangent slopes. Now I have negatives. So I have what looks like a parabola that's opening down, so that's a relative max or local max. Take the 0, plug it back into the original function. That's the y-coordinate 0. All right, then, well, let's see what's happening here. Negative to positive. I'm decreasing and changing to increasing. Oh, that's like a part of the parabola that opens up. That's a local or relative min. At x equals 1, put the 1 up in here for x. 1 minus 3 halves, negative 0.5. All right, remember B, that had the two negatives on both sides of 0 and the 3 halves of the positive here. There's no sign change here on either side of 0, so there's no max or min there. Negative to positive, just like we had here with a 1. That's going to be a min. X equals 3 halves is going to be the location of that min value. We got to plug it back in. Probably once your calculator crunch the values, we get negative 27 over 16. That's the y-coordinate of the local or relative min. That's your minimum value. Remember, maxes and mins are always the y-coordinate, so we have to go find them when they provide the original function. Okay, let's try these functions. Oh, these are a little different. Let's see what's going on here. F of x equals 1/2 x minus sine of x on the open interval from 0 to 2 pi, so one revolution around the circle. Here we go. Let's take the derivative. That's going to be 1/2 minus the derivative of sine of x is cosine of x. Set that equal to 0. Solve it, so cosine of x equals 1/2. Oh, let's see. This is your 30, 60, 90 right triangle. So 60 is opposite the radical 3. 30 is opposite the 1. So cosine would be adjacent, which would be radical 3 over 2. That's going, oh, excuse me, that would be, let's see, 31/2. Yeah, radical 3. That would be a 60-degree angle. So pi over 3 and 5 pi over 3. Why 5 pi over 3? Remember, all students take calculus. Cosine is positive in quadrant 1 and 4, so we have to have a quadrant 4 angle. All right, so I make my number line. Pi over 3, 5 pi over 3. Look at the derivative function. Your function with x in it is negative, so the right-hand behavior is negative, then it alternates to a positive, then to a negative, because these have occurred once. So let's see, at pi over 3, decreasing to increasing, oh, that's a relative min, okay, or local min. Substitute pi over 3 back into the original function, so 1/2 times pi over 3 is pi over 6, minus sine of pi over 3, the 60-degree angle, that's radical 3 over 2. And if you want to multiply it both top and bottom by 3 to get it one common denominator, you can do that as well. And increasing to decreasing, that's that local or relative max. So 5 pi over 3 times 1/2, 5 pi over 6. Okay, minus sine of 5 pi over 6, so that puts me again, remember that's fourth quadrant, but for sine, there are negative answers down there. So a minus a negative radical 3 over 2 makes it a positive radical 3 over 2. And again, we can get common denominators and write as one fraction. D, f of x equals x to the fourth plus 1 over x squared. Here we go. We have vertical asymptotes. X cannot equal 0. In fact, that occurs twice. So that vertical asymptote is there twice. Okay, so to find the first derivative, we're going to have to do the quotient rule. F on the top, g on the bottom. Here we go. X squared times the derivative of the top, 4x cubed, minus the derivative of the bottom, 2x, times the original top function, x to the fourth plus 1, all over the bottom g function squared. So that's going to turn in x to the fourth here. But I see some GCFs here. I can take out a 2, I can take out an x. So let's do some factoring, or better yet, if you multiply these together, I see x to the fifth and another x to the fifth, which we could combine those. You can factor and cancel, it's still going to work out. Okay, so multiplying this together, we get 4x to the fifth minus 2x to the fifth, which we can combine that to 2x to the fifth minus 2x. And now we can factor out a 2x. So it's going to happen whether you take out the GCF up here or you take it out down here. So I factor out the 2x, which would be right here in the front, but because this x and there's an x on the bottom, I just went ahead and reduced that power by 3. So when I was writing this out, I said, why bother writing the x's just to put on the slash through them? So x to the fourth minus 1 is set equal to 0, which means x is equal to plus or minus 1. So graph those number lines. Now again, notice, add 0, I put that in there because that's technically a critical number, those vertical asymptotes. All right, but now, again, it doesn't occur twice. Look at the first derivative. It's x cubed. 0 occurs 3 times. If you want to put a little subscript 3 there, you should do that because now, since it's occurring an odd number of times, your signs will alternate on either side. Okay, right-hand behavior, positive 2x to the fifth, positive x to the fourth on the bottom. Those are your leading terms. Positive divided by positive is positive. Then alternate negative, alternate positive, then negative. So from negative to a positive, let's see, that's going to be decreasing to increasing. That's going to be a local min. Take the negative 1, plug it back into the original function, and you get a 2. Vertical asymptotes, cannot be a local max or min. Nothing's there, so skip that. Let's go over to here. Negative to a positive again, that's a local min. Well, plugging in a positive 1 should still give you a positive 2. And there's my 2 local mins. Example 3, here we have a graph of f prime of x. All right, they want us to find on what intervals is f increasing and decreasing, the original function. So I need to find where I have positive y's, that's increasing, and negative y's, that's where the original graph is decreasing. Darn this mouse. All right, so f prime of x is greater than 0, from 0 to 1, and from 5 to 7. I'm decreasing now when f prime of x is less than 0, when I have negative y. So that's going to be from 1 to 5 and 7 to 8. Now, even though those are closed circles, these have to be open intervals, no brackets on those endpoints. At what values of x does f have local extremes? So we can find maxes or mins here. Okay, here's my critical numbers at 1, 5, and 7. That's when f prime of x is equal to 0. That's when we have horizontal tangents on the original function. So at 1, I go from positive to negative. That's a local max. Now here I can't find the y-coordinate of that point because I have no idea what the original f function is. At 5, we're going from negative to positive. All right. So again, decreasing to increasing. That's a local or relative min. 7 is positive to negative or increasing to decreasing. So that's going to be a local max at that 7. All right, we're going to take a break here because this is a long section. See you in part 2. if I ever get there.